Okay, example 3, again, this is kind of a left-right structure. So again, you should feel very happy since the Y bar will be easy to calculate. Right. A composite beam is fabricated by bolting two 4-inch wide, 10-inch deep wood planks, the yellow colored things, to the size of a 1/4-inch by 10-inch steel plate. They have the same height. Right. The modulus of elasticity of wood is 1,800, that of steel is 30,000 KSI. And this simply supported beam span a distance of 15 feet and carries two concentrated load, which are applied at the quarter points of the span. Then step A, determine the maximum stress produced in the wood, plank, and steel if the P is given. Then the step B, that P is not given, assume that the allowable bending stress of wood and steel are 1,200 psi and 24,000 psi. Determine the largest acceptable magnitude of load P. Ignore the self-weight. Okay, so the first one, the step A, will be analysis, right? Just give you a P to analyze the bending stress. And the B will be a design problem. Okay, we don't know the load P, we just know the material property, the strength or allowable stress. Based on that, you can select the P, determine the maximum P that is allowed to be applied on this structure. Okay, these are two different directions, opposite directions. Okay, but we can summarize them together. We can solve them simultaneously. We can see how we can do that. Okay. So let's look at the first step A. Okay, the A is asking you to determine the maximum stress. Right, so the maximum stress will need to be calculated from max moment times C, right, so over I. Right, from here, so we first of all, the first step, we need to determine what is the maximum bending moment, right, from M diagram. Right, second step, we will transform section. Then the third step, calculate Y bar and I, then calculate. Right. Those are the general steps. Okay. The first step, as shown here, the first step is to use free body diagram and then determine the reaction forces, then draw the V diagram and M diagram. Okay, I will skip this. Right, this is easy enough structure. Okay, this will be easy enough, right? Structure. So we can determine that AY equals P, DY equals P. Right. So during this calculation, we just carry P as a variable since we do not know the P. Right? We just carry it as a variable, as an unknown. So based on this, we can draw the V diagram as shown here, just a P between AB and negative P between CD and nothing on BC. Right. Then on that, we calculate the area A1 and then the A2. Then we can draw the M diagram here. So you can see that the maximum bending moment is 5P, right? P times 5 feet. Okay. So here we have determined that the maximum bending moment is 5P, right? Since we assume P is in kips, okay, so the unit will be kips feet. Okay, this is very important, okay, since we will need to use this unit later during the real calculations. Okay, the second step, we will transform the sections. we will select steel into wood. If we select steel into wood, then the steel will become much wider. So you get the wood unchanged. Right. So as we shown in example 2, the Y bar will be easy to calculate. Right. So here let's calculate the N first. The N is wood is the base, so the larger value, 30,000 over 1,800, we get 16.7. And the Y bar will be Y bar will be half of the height, right? Will be half of the height. Since here the H is what? H is 10. So here H is 10, so here is 5 inch. And the I will be sum of these 3 ICIs, right? It's a 4.17 times 10 cube over 12. The side here is 4, side here is 4, and the side here is what? It's 1/4 times 16.7 equals 4.17 inch. Right? So that is how we got this 4.17. Right? Plus 4 10 cube over 12 times 2. So we have 2 of them. Right? So we get 1014 inch to the 4th. Okay, so we have calculated these properties, and then we can solve the stress. The maximum bending stress in the wood will be P kips times 5 feet. This is the bending moment, right? These are the bending moment times 12,000, right? It's converted into pound inch, right? Times the distance is half of the height, right? It's 10 minus 5 over 1014. So here we get 296 PSI. Okay, this is in PSI, but we have a variable here in P. Use this result, we can just solve step A and step B simultaneously. Right, this, okay here, so if P equals 5 kips, then the maximum stress will be 1480 PSI. And this is our step A. And step B. So if the allowable stress in wood is, if the allowable is 1,200 PSI, and the P has to be smaller than 1,200 over this value, right? So 296. So this will be 4.05 kips. And we also need to check the maximum stress in steel. But since steel is fictitious, right? So we need to multiply it by N. N times M max times Y max over I. Right, you can try to solve this by yourself, right? Just here you will get 4943 psi. Again, we'll divide it into two steps. A, if P equals 5 keeps, then the maximum stress will be 24,715 psi. If the allowable stress equals 24,000 psi, then the P should be not higher than 24,000 over here, 4943. Okay, this will be 4.86 psi. Okay. Then for step A, this is okay. So we just need to determine the maximum stresses in the wood and in the steel, and they have been determined. But for the B, for the design problem, you still need one more step. Since we have determined P cannot be larger than 4.05 here, and cannot be larger than 4.86 here. We need to select one of them as the final report, right? So for the B, we need to do that P should be not higher than the smaller one in 4.05 and 4.86. Obviously, that is 4.05. Keeps. Okay, here should be keeps. Okay, so this is our final design reports.